Hello, this is the third and final video of our three-part Quick Install and Setup series. In this video, we'll quickly create a simple yet powerful rule set with the SoftHub configuration utility. We'll load that rule set into our Raspberry Pi we've set up in the previous video. We'll start the SoftHub daemon, and then, assuming we've done everything correctly, we'll see our packet showing up at both the public Mosquito MQTT broker as well as the AWS-hosted packet capture server we previously configured. Here we've opened the SoftHub configuration utility and started a new rule set. We'll start by choosing a sensor we want to connect to and enabling a few of the values the sensor reports. We're going to select the Moat Smart Climate sensor, but you can choose any supported sensor that you have access to. We'll also create an event to be queued whenever a new packet arrives from the sensor. Next, we'll create two action objects, one to publish the incoming packet data to the Mosquito public MQTT broker, and the other to also forward our packets to our AWS packet capture server. We'll create a single rule to be evaluated whenever the new packet event occurs. And we'll select both our two action objects to be executed. And that's it. By default, the SoftHub is set to auto-connect to all sensors selected, so that's all we need to do. This very simple rule set tells the SoftHub to initiate and maintain a connection to the specified sensor, and then whenever a packet arrives from that sensor, to publish it to the Mosquito broker and to also send it to our AWS packet capture server. We'll save the file and then use the pscp command to push it over to the appropriate directory on our Raspberry Pi. Now we hop over to the Raspberry Pi and restart the SoftHub daemon so that it reads in our new configuration rule set. We'll open the MQTT FX utility, and using the Mosquito server profile we've previously configured, we'll connect to the public Mosquito MQTT broker. Similarly, we'll subscribe to the same topic we specified to publish to in our rule set, in this case, OmnIoT/demo. And here we see our packets arriving at the Mosquito broker and being echoed back out on the topic we specified. Since the JSON packets are sent compressed to save bandwidth, we'll grab a packet and run it through the online JSON lint website to see it in a more eye-readable format. Lastly, we have a remote desktop session open to our AWS server. Normally, the packet capture server runs as a Windows service and then passes each decoded packet to a user-defined packet receiver DLL. But for this example, we're going to run it in debug mode as a straight exe, and we're going to use the supplied example packet receiver DLL that simply prints each packet to the screen. So when we start the packet capture service utility, we'll see the packets print to the screen as they arrive. Note the initial flood of packets we receive. This is because by default the SoftHub will cache any packets it is unable to send while it waits to establish a connection with the target remote packet capture server. And that wraps up our three-part series where we've created and configured our Raspberry Pi from scratch, installed and configured the SoftHub Platform, and run a simple test rule set to confirm that the SoftHub components are working correctly. Again, as stated in the first video, this is just meant to be a quick guide to get you started. Be sure to read over the installation materials thoroughly when doing your own install. Also bear in mind that SoftHub offers much more functionality than we've presented here. Check out our YouTube channel at OmnIoT Videos for lots of additional example and how-to videos. Thanks for watching.